Hello there, my name is Nenad Pelancic. I'm Global Application Manager at Infineon. What you see here is how we at Infineon are enabling and revolutionizing robotics. I'm going to show you three main demos we have today at the Embedded World. The first one, what you see here, is a robot arm. And it's not just a robot arm, it's something that we have done with our latest and greatest gallium nitride semiconductors together with our PSOC Control C3 MCU paired with the latest and greatest current sensors. It's as well enabled with a PSOC Control C3 microcontroller, what you can see here. Then we have half-bridge IPS, so power stages, to replicate the three phases for the motor control, together with some position and current sensors here on the edges. It's a bit bigger than the previous board what I have shown, but this is also certainly able to have a higher current capability, so also feasible to use in bigger joints for the humanoid robots. But the same concept here will apply. The better and the easier we can shrink the size for space constraints modules to dissipate more power with less losses, with a better thermal dissipation. This will basically win the designs in the future. For humanoid robot especially, size does matter. And here we will see that the shrinking of the PCB area together with the MCUs will be the key. And this is one way that we at Infineon are going to show our customers and the world how you can make your motor control even smaller. So what you see here is more on the sensor side for humanoid robots. If you think about robotics, like we humans, they need to know where they are around, usually replicating their eyes, replicating the ears and the senses. And what we have achieved here is a 360-degree awareness. We humans, we have two eyes, but what we can achieve with a humanoid robot is to make a head rotate. But what is more the essence here is that we are utilizing the latest PSOC edge controller to be the main MCU for coordinating, especially what you see here in the front, which is a radar and time-of-flight camera. As you can see here as well on the screen, when I move or when I move with my body, this robot is as well moving. So this is going to be some feature that we will see more and more in robotics. And the benefit here is this can also see in the dark. Where we have paired this together is as well, not just on the sensor side, but as well on this similar concept as you have seen in the previous demo, that you still will need a rotation for your head for motor control. Similar concept as there with our latest PSOC control. But the highlight for this one certainly is the radar technology, the time of flight and the sensors. It's a bit too loud here, but usually we could command this one as well by voice command to basically change the color, or in the future certainly the robot has hands, you can tell it, hey, please clean this, or please go to this room. So basically a bit of our verbal commands will be the future going forward for humanoid robotics. So what you see here is a CapSense technology for Infineon. It's not just CapSense. If you think about humanoid robots, they are pure metal. What we are inducing here is two solutions. First of all, it's a humanoid skin, which is our latest demonstrator, what you can see here. We will interface and work together more with robots, and that they can basically replicate the human skin. It's important to try and to enable the same behavior as we humans have in the skin into the robot, which means if I push a robot, or even if I come close, it should move away. And this is what we are showcasing here in this demo. So wherever you press, you can see that the haptic feedback comes into it. So the benefit here is it's with a PSOC 4. It's a special material, and you can have multiple basically arrays that you can detect just with one device, a bigger area. On the other hand, using the same PSOC 4, what you can enable is to put it not on a big scale, maybe on the hand, it can be on the chest, but you can put it on the fingertips. So dexterous hand is going to be the next big thing in the next years that we have to find solution for. And one of those is this PSOC 4 CapSense, where it's going to be important for the dexterous hand in the humanoid robot to know how strong it is squeezing something, on what angle, and basically where maybe to squeeze a bit more if something is slipping. And this is what we are demonstrating here on this fingertip of this robot. This is a material of glass, but we have the similar concept here with a fabric one. So the material in the end is not basically restricting the usage. It's basically the same chip, the same solution. It's up to you designers out there what material you put in the front. Of course, specific physical characteristics need to be in place to conduct the electromagnetic fields into the PCB.